Hi YouTube, Unkert here. In this video, we're going to look at the math module in Python. Now, if I go to my browser here, I have docs.python.org/3/library math.html. So you can learn more about the math module from this web page. I'll leave the link in the description. Okay, so let's create a new file. And let's call it math_module.py. Okay. And let's get rid of the sidebar here. And to use math, we have to import it. So we'll import the math module. Okay. And what we can do is now start to use functions in the math module. So one function that rounds a number up, even if it's like 0.1 or round it up to the next integer, is the math.ceil function. And so we can do math.ceil and then pass in a value. So let's pass in 3.1, and this should output 4. Okay, so let's open up a terminal here, and we'll do Python 3, and then the name of the file, which is mathmodule.py, and we see it rounds up to 4. We also have a floor function, so we can do math.floor, and we could do something like 3.9, and no matter what, this is going to round it down to 3. Okay, so let's run this, and there you go, it rounds down to 3. Okay, we could do the factorial of a number. So like the factorial of 5 is 5 times 4 times 3 times 2 times 1. So let's just write that in the comments. So a factorial of 5 is 5 times 4 times 3 times 2 times 1, which is 120. Yeah. So let's print. We'll do math.factorial. Okay. And we'll do 5. Okay. And let's run this. Okay. And we get 120 as expected. We could do the absolute value. Okay, so we could do print and then math dot, and then I think we have, let's see, we have ABS? No, we have FABS. Okay, so this will give me the absolute value. We can do a float. So let's do negative 3.5, and it should output positive 3.5 because it's the absolute value. The distance the number is away from 0 on the number line. Okay, so we get 3.5 units away from 0 on the number line. Okay, we can also pass in an iterable and calculate the sum of that iterable. So we could do print, and we could do math.fsum, and we can pass in, let's say, a list. And let's do, so it supports floats. Let's do 1, 2, 3, 4, 5, and that should calculate the sum of 1, 2, 3, 4, 5 as a float. So we should get, let's see, that's going to be 12, 14, 15. We should get 15.0. Okay, let's run this, and we get 15.0 as expected. We can pass in an iterable and calculate the product. So we could do math.prod, okay, and do another iterable, okay, and so let's do 1, 2, 3, 4, 5, and let's run this, see if this works the same, and we get 120, which is the same as the factorial of 5. Now, if we just, added a random number in here, like, I don't know, 10, it's going to multiply that previous result 120 by 10, so we should get 1200. Let's run this, and we get 1200. Okay, so that's prod. Okay, we can do logarithms, so we could do math.log, and we'll do the value and then the base. So let's do 8 with a base of 2. I believe this will work. Let me just check this, and yeah, and we get 3 because 2 cubed is 8. Pretty cool. We could do a log with a base of 10. So math log 10, and let's do 1,000. This should also give, let's do 10,000. So we get 4. because 10 to the fourth power is 10,000. Okay, so we should get 4. Yep, we get 4.0. Okay, so it's returning that as a float. Pretty cool. We can, instead of using the double asterisk, we can use math.pow. So we could do print and then math.pow. And then we see we have a base and an exponent. So this here should give me 8. That gives me 8.0 as a float. Okay, we could do the square root. So we could do print and then math.sqrt. And let's do the square root of 9. That should give me 3. Okay, so if I run that, I get 3.0. Again, we're returning floats. We can do constants here. So we could do, math.pi, and that's going to print out the value of pi, right? So 3.14159, etc. Okay, and we can use this to use it in trig functions. So we could do print and then math.sign, and we could pass in math.pi and divide that by 2. And depending on the accuracy, we should get 1 for this. So let's run it. Yep, we get 1.0. Now let's try this out with cosine. If we do math.cos of math.pi divided by 2, we should get 0. But let's see, okay? And we don't quite get 0 because there is a little loss of accuracy. You see 6.12 e minus 17, so times 10 to the negative 17th power. So that's like, a bunch of zeros before that 6. So very small number. So there is a little rounding issue. Now let's try, and this happens in Ruby as well. So let's do math.tan, and we'll do math.pi divided by 2. Now this should be undefined. Let's see what happens in Python though. And we get 1.6 times 10 to the 16th power. So we get a very big number, but we don't get undefined. So again, that's due to the loss of accuracy a little bit with the floating point number. So that's something to take into account. We can also do radians to degrees. So let's do math.degrees. And let's pass in math.pi divided by 2, which should give us 90. And we get 90.0 as expected. We can also do math.radians and pass in a degree value. So let's pass in 90. We should get pi divided by 2, which is like 1.57. So let's run that, and we get 1.57, etc. Okay, we could do Euler's number. So let's print math.e. Okay, that's Euler's number, which is a very important number. And there we go, 2.718, etc. Okay, we can also figure out the hypotenuse of a right triangle if we have the legs. So if you know Pythagorean triples, the first one is 3, 4, 5. So if I do math.hypot and then pass in the legs 3 and 4, I should get back 5.0. It's returning a float. So we run it, we get back 5.0. Okay, so you can pass in any legs of a right triangle and get back the hypotenuse. Pretty sweet. Now, with this module, as with other modules, like for instance the random module, we could import it like this. Let me just delete all this stuff. But we could import math as m, okay? And then if we want to use it, we could do print and then m dot, and then access the functions that way. So seal. And then we could do, let's do 4.1. Okay, and if we run it this way, so this will allow us to type a little bit less if we wanted to do it this way. And we run it, and it rounds 4.1 up to 5. So we're accessing those functions. We can also just import a function. So let's say we just want to import the floor function. So we could say from math import floor. Okay. And now we can go here and do print, and we can just call the function. So we can do floor, and let's do, 5.9, which should give us 5. Okay, so if we run that, we get 5, okay? We can also import all the functions here. So let me go to the beginning here and just delete everything here. I could say from math import and just do an asterisk, and that's going to import all the functions. And now I could just use whatever function I want. Let's say I want to use the hypot, and I don't have to do math dot. I can do hypot and do, let's do a 6, 8, 10. Or no, let's do something interesting. Let's do 5, 12, because that should give me, I think, 13 as my hypotenuse, 13.0. And there we go, 13.0. Okay, so this demonstrates the math module using it that way, but also the different ways you can import functions into or from modules. So you could use a random module, you use whatever module you want, and use this technique to bring in the functions and access them that way. I hope you found this video interesting. If you did, could you give it a like and subscribe to the channel? Thanks for watching.